Hello everyone, and welcome to the Mat 211 review on linear programming. My name is Julia, and I work for the tutoring centers at ASU. So for our problem, we have a calculator company produces both scientific and graphing calculators. Projections show an expected demand of at least 100 scientific calculators and 80 graphing calculators each day. So at least 80 graphing calculators each day as well. Due to limitations on production, no more than 300 scientific calculators and 250 graphing calculators can be made per day. Also, to satisfy a contract, at least 220 calculators must be shipped each day. Each scientific calculator sold is a $1 loss, while each graphing calculator sold is a $4 profit. How many of each type should be made to maximize the company's profit? So let's first start by coming up with a system of inequalities that represents this part of the problem. So from the problem, we know that we have at least 100 scientific calculators. So let's let X be the number of scientific calculators. And let's let Y be the number of graphing calculators. So since we need to have at least 100 scientific calculators, we know that X must be greater than or equal to 100. Similarly, we can only produce no more than 300 scientific calculators. So we know that X is less than or equal to 300. Looking at the graphing calculators, we have at least 80 graphing calculators. So Y is greater than or equal to 80. And no more than 250 graphing calculators. So Y is less than or equal to 250. Lastly, to satisfy our contract, we have to have at least 220 calculators total shipped each day. So that means that our number of scientific calculators plus our number of graphing calculators, so X plus Y, must be at least or greater than or equal to 220. So this is a system of inequalities. We can write this one as 100 is less than or equal to X is less than or equal to 300. And we can write this one, if we choose, as 80 is less than or equal to Y is less than or equal to 250. But it doesn't matter. Whichever the two ways you like is fine for this. Let's also determine our profit equation based on this part of our problem. So we know that, so let's call P our profit. We know that each scientific calculator sold is a $1 loss. So we can say that -1 times X, the number of scientific calculators. And then we know that each graphing calculator sold is a $4 profit. So we can say plus $4 times the number of graphing calculators, Y. So let's just simplify this to -X plus 4Y. Okay? And we'll just move this P over here so it's not confusing looking. There we go. All right. So now that we have all of our equations sorted, we can graph the inequalities, so our system over here, to figure out what our solution space is, our shaded region. So let's just do that. So we'll make just a real rough graph here. It's nothing pretty. But we have our X and our Y axis, X and Y. And let's say that this is 100 for our X. So we've got our, I'll make it red. We've got our X is greater than or equal to 100 here. And let's say that this is 300 over here, and x is less than or equal to 300. So we know it's going to be somewhere in this space here. Then for our y, let's say this is 80 here. And we know that y has to be greater than or equal to 80. So in there. And we know that y has to be less than or equal to 250. So let's say this is 250 here. And here's our 250 line. So we also know that our solution space has to be in between these two lines. So we know it's going to be somewhere in this box in the center, right over here. But the last thing, we have one more inequality here. So we have that y, or x plus y, is greater than or equal to 220. So let's rewrite this. We'll just subtract the x over to this side just to make this easier to graph. So this would be y is greater than or equal to 220 minus x. So we can say this is about 220 here. And it's going to go down at a 1-to-1 rate. So something like that. It's probably not exact, but you get the idea. And we know that it has to be at least this. So it's going to be above the line. So our space, our solution space here, is going to be in this region here. So bounded right here. All right. So our solution set is bounded, and there are 5 corner points. And we know that this profit function is going to be maximized at one of these 5 corner points. So we'll call this one, just for keeping track of things, we'll call this one 1. Call this one 2. We'll call this one 3. We'll call this one 4. And we'll call this one 5. Okay, great. So what we want to do is we want to figure out the points for each of these. So one's a little complicated because we have this sloping line here, and it's intersecting. So that sloping line is our function y is less than or equal to 220 minus x. And then we have, it's intersecting with x equals 100. So for our first point here, we have x equals 100 and y is equal to, because we're just looking at the equality portion of it right now, 220 minus x. So we can just substitute this x equals 100 into this equation here. So that gives us 220 minus 100, which equals 120. And then we can substitute, well, so that's our x value and that's our y value. So that gives us our first point here is, we'll write it over the side here for now, is going to be 100 and 120. So for our second point, that's pretty straightforward because we just have the 2 lines. Let's write this over here first real quick, just to make it neat. 120. All right. So for our second point here, we just have the 2 lines, x equals 100 and y equals 250. So our point is just going to be 100, 250. So let's write that in so we don't run out of space. Similarly, our third point is bounded by x equals 300, this line, and y equals 250 again. So we know that our third point is going to be 300, 250. That's a 2. That's a 5. Our fourth point is bounded by x equals 300 and y equals 80. So we've got 380. And then for our fifth point, we again have to go through and solve for the intersection between our line here and x equals, or excuse me, y equals 80. So we've got y equals 80, and we've got y equals 220 minus x. Well, we'll just substitute this in for y. So that gives us 80 equals 220 minus x. You can subtract this 220 over to this side. That gives us negative 140 equals negative x. Clean that up so it's easier to see. Oops. Rewrite it. All right. And then if we, multiply everything by negative 1, we just have 140 equals x. So that gives us y equals 80 and x equals 140. So 140 and 80 is our last point. Let me make a little space here again. So the last thing we need to do is we need to evaluate our profit function, p equals negative x plus 4y at each of these points. So let's do it just for the first one, and then I'll let you guys try it at home for the other ones. So we have p equals negative, for this first one, negative 100 plus 4 times 120 equals negative 100 plus 480 equals 380 dollars. So we know this is 380, so let's just clean this up here, and we'll just say that this profit for point 1 equals 380. Oop, that's supposed to be an 8. 380. There we go. All right, and the same thing for all of these other points. We're just going to plug our x and y values into our profit function. So you can go ahead and check this math at home, but we have profit for point 2 is $900. Profit for point 3 is $700. Profit for point 4 is $20. Not much there. And profit for point 5 is $180. So we want to maximize our profit. And just by looking at this, we can see that point 2 is our highest profit. So at point 2, that means that we're making 100 graphic or scientific calculators. So because X is scientific calculators. So that's 100, we'll just say sci calculators. And we have 250 graphing calculators. And that is the number of calculators of each type that we want to make in order to maximize our profit. So before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can go to tutoring.asu.edu to take advantage of all of our services. So that's this link right here. If you use the tutor search function at that link, which you can also get through right through this link here, the full link, That gives you the tutor search function at our website, which allows you to find tutoring services for your specific course. So thank you so much and have a great rest of your day.